Bismillahirrahmanirrahim. Today we are going to speak about computing the limits at a finite number. We have two types of the limits. The first one will be computing the limit at a given number, finite, and the second one will be computing the limit at infinity. Sometimes we call it the end behavior of the function. First of all, we need to define what do we mean by limits. For any function, start with example. We have f of x, for example, equal to minus 1. This is a function. For any function, we have two parts. The first part we call the independent variable, and the second part is the dependent or the output of the function. So we have independent variable, that the one that will control the output of the function and the output. So if we draw a table like this, and I will choose or write x because my dependent variable or independent variable of this function is x. It is f of x. So x, we call it independent variable. This is independent. And we have the output or the dependent, which is f of x. For the independent variable, we call independent because we can choose any value for x. I can choose any value for x, and that will give me some output for the function. Let's start take, for example, if x equal to 1. Let me choose x equal to 1. Replace x or substitute x in the function. In the function, I will have 2 multiplied by 1 minus 1, which is equal to 1. So when x equal to 1, f of 1 will be 1. The output is equal to 1. Now if x equal to 1.5, see what the output will be 2 multiplied by 1.5 minus 1. That will be 2 multiplied by 1.5 is equal to 3 minus 1 is equal to 2. If x equal to 1.7, I will have 2 multiplied by 1.7 minus 1, that will be 2.4. If I have 1.8 for x, it will be 2 multiplied by 1.8, that minus 1, which is equal to 2.6. If I have 1.9, then it is 2 multiplied by 1.9 minus 1, that will be equal to 2.8. So we notice one thing in this example. As x approach a number, when x is approaching the number 2, for example, I have 1, then 1.5, 1.7, 1.8, 1.9, we'll see that the function is approaching the number 3. So we say in this case, we say that the limit of f of x is equal to 3, but with one condition, because this output or the limit of the function is depending on the value of x. So as x approaches the number 2, so we'll say that the limit of the function is equal to 3 as x approaches the number 2. So we can say now, the limit of the function is the output of the function. The limit of f of x is the output of the function that depends on the value of x. Let's keep this in our mind. The output is changing depending on the value of x. If x is approaching another number, the output will be different for sure. If x is approaching the number 5, for example, 2 times 5 equal to 10 minus 1, the limit will be 9. So the limit is the output of the function, depend on the value of x. So we can say limit of a function f is the value can be attained. Depending on the value of x. Or in general, I can say depending on the value of the independent variable. So this is the limit of the function. And we usually write limit of x as x approaches the number 2 is equal to 3. This is the symbol of writing the limit. Limit of f of x as x approaches the number 2 is equal to 3. Now we will notice one thing now here. When we say that the limit of the function, or when x is approaching the number 2, this is number 2, and x is approaching the number 2. We know that for approaching the number 2, I have two sides. Either I can approach the number 2 from the left approach, or I can approach the number 2 from the right. So I have two sides or two directions to approach the number 2, left or right. And because of this, we say that we have two limits. For a function, I have two limits, left and right limit. So number 1, we have left limit for the function. Left limit. It means x approaching the number 2 from the left. X is going to 2, and we write it. We write as limit f of x as x approaching the number 2 minus, like the power minus means we are approaching the number 2 from the left. We call this is the left limit. So I have left limit that depends on x when x is approaching the number 2 or any number from the left. So x is less than 2. It might be 1.999. I can choose x to be 1.9999. So it is approaching the number 2 from the left. The second one, right limit. It means x greater than 2. And we write limit f of x as x approaching the number 2 from the right. In both cases, when we say that x approaching the number 2 from the left or x uprooting the number 2 from the right, it means also that x is not equal to 2. This we should keep it in our mind. In both cases, x is not equal to the number 2. It is uprooting the number 2. It can be a very close to number 2, either from left or from right. But it means also it is x is not equal to 2. And that's why in some cases, we will find the limit for the fractional function where at the given number, the function is undefined, but we need to find the limit, not the value of the function. And that's why we have to keep in our mind that x is not equal to that number, the given number. X is approaching from the left or from the right. X goes to 2 minus means left, x goes to 2 plus, power plus means coming from the right. Now, we have this statement now. It as a remark. If the left limit as x goes to 2 minus equal to limit f of x as x goes to 2 plus. If the left limit and right limit are equal, then we say limit of the function f of x as x goes to 2 without any sign, without negative or positive. If the two limits from the left and right are equal, we say the limit exists. The limit f of x as x goes to 2 without any sign, left or right, exists. And if left limit is not equal to they are not equal, we say that, then we say limit f of x as x goes to 2 without sign does not exist. And this will be used as a short, we say DNA. It means does not exist. So the limit does not exist. If the limit from the left is not equal to the limit from the right, we say that the function or the limit does not exist. And I'm going to explain this with more details with different examples later on. But before that, let me write some theorem, then I'm going to apply some or solve some examples. Theorem. Limit of some constant, or okay, let me say that, let a and b, or a and k, be real numbers. In a, the limit constant when x goes to a will be unchanged, it will be k. So limit of the constant number is still the same, will be the same, it is k, no change, because there is no x. For the limit, we are looking for the independent variable. If I don't have independent variable, means the limit will be as given like the constant function. It is unchanged. It will remain k. B, limit of x as x goes to a or approaches a is equal to a. This is direct substitution. Replace x by the given number. Number 3, or C, sorry. Limit of 1 over x. We know that the function or the rational function 1 over x is undefined when x equal to 0. The graph for this function when x is equal to 0 is undefined, but we know the shape of the graph is taking this shape for the positive and take this direction for the less than 0, it is negative. Now, when x goes to 0 minus, it means we are approaching the 0 from the left, from this direction. We are approaching 0 from this direction. Now we are looking for the value of the function. Suppose that I have moving car on the curve of the function. When we move in this direction, as we go to 0, it will go down. Go down for up to, this is 1 over x, up to minus infinity. It will go down for negative infinity or minus infinity. So the limit of the function 1 over x when x goes to 0 minus is minus 1 over, so it is equal to minus infinity. And if we approach the 0 from the right, then we are moving in this direction because we are approaching the 0 from the right. And this will be plus infinity. So limit 1 over x when x goes to 0 minus is equal to minus infinity, and limit 1 over x when x approaches the 0 plus is equal to plus infinity. The negative sign or plus for 1 over x depends on the sign of the numerator. And sometimes it also depends on the power of the denominator. For example, if I have limit, if we take the square root onto the square of the denominator, limit 1 over x squared. As x goes to 0 minus, this will be plus, because I have square, this is plus infinity. And also limit 1 over x squared when x goes to 0 plus, also it will be plus infinity. So these are some basic limits for the function constant or linear function x or 1 over x. And you can see that 1 over x is undefined when x equal to 0, but we are not looking for the exact value of the function. We are looking for the limit of the function. Limit of the function when x is approaching the number 0, either from left or from right. And one more. For any polynomial, p of x, that will be, for example, is equal to c0 plus c1 x to the power 1 plus c2 x squared up to plus cn x to the power n. If we have polynomial, the limit, and for any real number, a, the limit v of x as x goes to a is equal to v of a. Means just replace x by a. Limit of v of x as x approach the number a either from left or right is equal to b of a. That will be c0 plus, just replace x by a. Direct substitution. So that will be the limit for the polynomial. If we have a polynomial and we need to find the limit as x approach the number a, on what we need, just substitute x by a. So these are some basic theorems. So in this part I will stop at this point and I will explain these in more detail in the coming part, giving more examples to clarify the idea.